Well, hello there all you absolutely magnificent people, and welcome back to another episode of An Ecologist Plays. We talk about nature while playing games. My name is Will, I'm an ecologist by training, and we are back in Coral Island. As you can see here, we are just watering our crops, and after this we will of course be doing some other things. Our chicken coop, as you will see in a moment, is actually complete, so that means we can get some chickens. And off screen I have also cleared the ocean a wee little bit more, and I've gotten to the point where we can actually get silver kelp. And this does mean that if we can get more silver kelp, we can make more of these sprinklers. Which means that eventually I won't even have to water the plants this way at all. Our crops are coming along nicely now, but this is what I am really excited about. We have our coop over here. Now we can place 4 birds in here, either ducks or chickens or I think quails eventually as well. At the moment we can get ducks and chickens, I do believe, but I'm not going to get ducks yet because, well, we do need to have a pond for them, and we cannot make the pond as far as I know yet. But there we go, the ranch is open, so we can actually get our first little birdies. Let's have a look here. Indeed, we can get chickens, we can get cows already as well, we can get ducks, and we can get sheep as well. Now I'm just going to get some chickens here, and you know what, let's get 4 chickens here. And there we go, we have our 4 chickens right over here. We've got Amanita, named after the fly agaric mushroom there, Amanita muscaria. We also, right over here, have Hetty. I don't know why Hetty is a rooster, but anyway, we've got Hetty over here. We also have, right over here, Bandita, and then we have Latiporus, I believe this one is indeed, named after the genus that contains chicken of the woods. We are going to let them all outside a bit so they can come and wander around in this more open area. I'm going to actually place down a few more of these enclosures, and we can actually, as far as I know, we can move them around a bit from one coop to another. Indeed, if you go into the coop here, you can actually move them from one coop to another, it seems. So we can't do that yet because we only do have the one coop here. But once we have set up another coop, perhaps to the south over here, we can actually shift them over to that side and kind of rotate them from one coop to another, which would be a very nice way of doing things, being a little bit more natural, I guess. Right, now it has taken me most of the day, but I have cleared another little area over here, more or less cleared. We kept quite a few trees here, and I have also enclosed it in a nice little fence. And the idea is that we're going to put a second coop right over here, and then every few days we are going to rotate the chickens from coop 1 to coop 2, and then a few days later back from coop 2 to coop 1. I am also going to just buy some grass starter seeds and just place that down all over here to have some nice natural forage for the little chickens. Unfortunately, this little grazing area over here is not part of the fenced area around the second coop that we're going to have, but this will most likely form part of the third coop, because the more coops we have, the more we can rotate the animals around, and the more time we can give each little enclosed area to technically recover between being fed on by the chickens. Now, if my voice does sound different from the way it just did, that is because I just had to quickly catch a frog that was hopping around in our lounge, and I just had to quickly interrupt my recording session to safely release him outside. Now we have got quite a few things we can donate at the museum, so let's head on over there, shall we? And let's start by donating some artifacts over here. Then we also have the Gulf Fritillary over here, which is a caterpillar, and then we have the Violin Beetle, which is a very funky looking invertebrate. We'll chat about that one in a bit if we do see one again a little bit later. We've got a normal old moth, which is basically just a butterfly in disguise. And then we've got the Polyphemus moth over here as well, and a reward, which was the tap over there. Now we can place a tap on these trees here, and I think we're going to just place it on this one over here. I think this is going to give us maple syrup, if I'm not mistaken. But we'll have to wait a few days for that. For now though, let's just go to sleep. Now before we actually do anything else, we are going to call our chickens outside so they can enjoy the nice sunny weather we are having at the moment. Oh, look at that! I have already laid us some eggs here. That is wonderful. Now emerging from the grasses up here, we have the Violin Beetle. Now violin beetles are ground beetles, and they are predatory. At least as adults they are predatory. As larvae they actually feed on fungi. Their larvae dig into polyporous bracket fungi, and that is what they feed on. And then they pupate in those bracket fungi, emerge through a teeny tiny little hole, which their bodies technically shouldn't be able to fit through, yet they do squeeze themselves out through that. and then they emerge as these predatory ground beetles. Now, the reason they are called the Violin Beetle is because, well, look at that. The body is very, very similar in shape to a violin or a fiddle. And that is where they get the name from. The wing covers here, the elytra, are actually semi-translucent, so it allows light to shine through, makes it a little bit more difficult to actually spot the beetle. They really do have a very, very weird shape. Now, if they feel threatened, they can secrete a poisonous compound known as butyric acid, and that's a smell you get from rancid butter, because as butter goes rancid, it releases butyric acid through hydrolysis of some of the compounds in there, and that is what you smell. It's a pungent, colorless compound, and that is what the Violin Beetle will be using as its main defense. Of course, that's if the camouflage that it has fails. The fact that it has this weird shape means that it is more difficult to actually spot where the beetle actually is. Now I'm just quickly here to double check what we actually need in order to build another coop. Yeah, you see, we need bronze bars. We don't have enough bronze bars to actually make another coop. So as soon as I make more bronze bars, I will actually make the second coop. And then we can start moving our chickens around from one coop to the other. And speaking of smelling bad, we did just catch another Gulf Fritillary caterpillar over here. And as you can see there, it says there that they avoid predators by smelling bad. Stinking is a valid strategy to try and reduce predation. And yeah, the Gulf Fritillary, it is a species that typically would use chemical defense to try and avoid predation. Now, interesting, the scientific name of the Gulf Fritillary, it's a beautiful butterfly, by the way, beautiful orange butterfly, orangish color that does kind of indicate that, yeah, this is probably a poisonous species, leave it alone. But the scientific name is Dione vanillae. Vanillae referring to the fact that when this butterfly was described, it was drawn on a vanilla plant, vanilla orchid, but it doesn't actually feed, at least the caterpillars here don't actually feed on vanilla orchids. Instead, they feed on passion flowers. So they're also sometimes called the passion butterfly because the larvae occur on passion fruit, on plants in the Passiflora genus. And of course, passion flowers are actually poisonous, or they do contain toxic compounds, yet the caterpillar here will feed on that and then most likely will accumulate some of those toxic compounds in their bodies to act as a defense as well, along with that bad smell that they can produce. Now, I'm tired of not having enough space in my bag, so I'm going to upgrade my bag here. I had enough money to do that. And then we're going to go diving after donating the shallot that I found. So let's head to deeper waters and see what we can actually find. Ah, there we go. Immediately starting with one of these little altars. Now we have got a very interesting shell over here known as Murex. There we go, there is the Murex. It says it's spiky and pretty, and the spikes there on it most likely would be a defense against crabs, because in some areas where there aren't any crabs as predators, the Murex shells actually have very few spines. And then in other areas where crabs are present and really a dominant predator of the Murex, the shells have more spines. So the Murex is a type of sea snail, and of course they're not able to move very fast, and crabs able to then catch up to them and possibly break open the shell slowly but surely. And the spines there strengthen the shell and make it a little bit more difficult for the crabs to actually open up the shell. And that being able to have more or fewer spikes depending on how many predators there are in an area, that is an example of what we call phenotypic plasticity, which is when a species has the genes to do a variety of things. The genes code for a variety of things, for example, having more or fewer shells, but the phenotype, in other words, how those genes are actually expressed, that is dependent on environmental stimuli, like for example, the presence or absence of predators. Let's just also see, what have we got here? A cherry stone clam. So a typical bivalve meaning that they have two shells. We are just slowly but surely opening up the ocean here, removing the trash, and I think this is a whelk, if I'm not mistaken. There we go, indeed that is a whelk. We have of course previously found a whelk in the trash, and we have already donated it to the museum. Ooh, look at that! We've got a Seadragon over there. That is a relative of the seahorses. So it's in the Cygnathidae family, a relative of seahorses and pipefish. We're just going to try and catch it, please. There we go. And voila, a ruby Seadragon. So as you can see here, it says they've got a long red snout. Yes, that indeed. And its red color acts as camouflage in deep water. Ooh, That is awesome. That is an interesting point right over there. Oh, we've got mandarin fish swimming around all over the show here by the coral here. But why would red be camouflage in deeper water? That's because within the first few meters, generally about 6 meters to 7 meters, red light fizzles out. The red spectrum of light is actually a very lazy wavelength. It is not able to penetrate into water very far. So after about 6-7 meters, you have very little, if any, red light actually being present. So an object that is red, if you shine light on it, that actually does not appear red in deeper water. After about 6 or 7 meters, if you, for example, were to bleed, your blood wouldn't be red. In fact, it would appear green because there's no more of the red part of the light spectrum actually present in order to then reflect off your blood to make your blood appear red. Instead, your blood appears green because there are underlying green pigments that are present in your blood, but it's usually overshadowed by the red of your hemoglobin. So yeah, in deeper waters your blood would appear green, and the red ruby sea dragon here would not appear red because there's no more red light to actually make it stand out from green things and blue things, especially from green things in the background. So yeah, red here. A lot of deep sea creatures are in fact red in color simply because you're generally invisible, kind of invisible in deeper waters if you are red in color. Now, what is also interesting to note about the ruby sea dragon here is, the picture here actually shows them with these little dermal appendages. In other words, these little leaf-like skin appendages. But the ruby sea dragon actually lacks those. The leafy sea dragon and the common sea dragon, they would have it. But the ruby sea dragon generally lack those leafy appendages. It was also only very recently described in 2015, in fact, and there have been very few records of the ruby sea dragon overall. On iNaturalist, I believe there are only 5 records of this species. They're all from Western Australia, southwestern Australia, where this fish occurs. And interesting to note that the first specimen to ever be collected of this fish that was used to describe the entire species was in fact a male brooding babies. So, like other fish in the Cygnathidae family, or seahorses and pipefish, male sea dragons will brood the eggs in a special pouch, and then they will give birth to these young, to live sea dragonlets, I guess you could call them, when they hatch. So, yeah, that is such a cool group of fish. Now, although not formally described as endangered, they most likely are threatened to some extent, but they are classified at the moment at least as data deficient because, well, we don't know how rare they actually are because there have been so few sightings of them, but I guess it's safe to assume that they are most likely very, very rare. So we are going to be donating this little dragon to the museum, and then we're not going to catch any more of them because, well, I do not want to make money out of the catching and selling of endangered species in this game. So there we go, we can donate our little ruby sea dragon there. And when you look at that, the salted eggs are done. Let's actually sell these. Let's see how much we get for each of those salted eggs. Well, not a lot, but it is something at least. But you know what, that is where we are going to call it a day, everybody. So thank you very much for joining me on our little adventure. Hope you had fun. I had an absolute blast. Between now and our next episode, I'm going to do some mining and try to get the second coop as well, so that we can start rotating our little chickens. Of course, if you have any questions or comments, please pop them down in the comments below. And also just a massive thank you to everybody for watching this video, for supporting me that way, and also for our channel members. You guys really are awesome. Until next time, everybody, stay safe. I'll see you all soon. Cheers.